The title promises an investigation of the SL-1 reactor accident, but the supplied evidence does not document SL-1 at all. It contains no verified date, location, reactor design, personnel record, accident sequence, casualty count, investigation finding, or corrective action connected to that event. The only substantive source excerpt concerns a different disaster, the 1986 explosion of Reactor 4 at the Chernobyl nuclear power plant. That mismatch is not a minor editorial problem. It makes the central claim, the description of SL-1 as the deadliest United States nuclear reactor accident, impossible to establish from the available record. Repeating the title as fact would manufacture certainty. Filling the gaps from memory would introduce unsupported details. And borrowing Chernobyl's mechanisms to explain SL-1 would falsely connect two separate reactor accidents. So the decisive question cannot yet be answered responsibly. What physical action initiated the SL-1 accident, and what technical, organizational, and ethical conditions allowed that action to become fatal? A rigorous reconstruction would need evidence for several distinct layers. First is the proximate event, what physically happened in the final moments. Second is the technical root cause, what properties of the reactor and its safety systems transformed that event into an uncontrolled release of energy. Third is the organizational cause, how design review, training, maintenance, supervision, procedures, or institutional assumptions shaped the conditions. Fourth is the ethical question, whether known hazards were communicated and controlled appropriately. None of those layers can be inferred merely because another nuclear reactor also suffered an accident. The supplied Chernobyl account illustrates why those distinctions matter. According to that excerpt, Chernobyl's Reactor 4 exploded on 26 April 1986 during a test intended to simulate cooling under blackout conditions. Operators proceeded after an accidental reduction in reactor power, and pervasive design flaws contributed to a power surge when the reactor was shut down under those conditions. Components ruptured, coolant was lost, steam explosions and a meltdown destroyed the reactor building, and a core fire spread radioactive contamination. That is a documented sequence for Chernobyl. It is not evidence for the sequence at SL-1. Even broad similarities would be unsafe to assume. Nuclear reactor describes a large family of engineered systems rather than one universal machine. Different reactors can use different structures, coolants, control arrangements, operating missions, and safety strategies. An explanation that is accurate for one design may be irrelevant to another. The Chernobyl excerpt specifically identifies an RBMK reactor using water circulated by electrically driven pumps. It describes concerns involving continued cooling after shutdown, backup generators, emergency cooling, and a proposed use of turbine momentum during a power interruption. Without an SL-1 source, there is no evidentiary basis for assigning any of those features, vulnerabilities, or accident mechanisms to SL-1. This also prevents a responsible account of the intended experiment or mission. To establish expectation versus consequence, the record would need to say what SL-1 was built to accomplish and what researchers or operators expected from it. That purpose would frame every later decision. A test reactor, a commercial power reactor, and a reactor intended for a specialized institutional mission can expose different trade-offs. Their operators may confront different schedules, maintenance demands, and definitions of acceptable risk. But those distinctions must come from documentation, not narrative convenience. The same restriction applies to early success. A rise and fall account requires evidence showing why confidence grew before the accident. That could include operating history, completed tests, institutional assessments, or accepted design assumptions, but none appear in the source pack. Confidence cannot be reverse-engineered from the fact that a failure eventually occurred. An accident does not prove that everyone had been complacent, just as previous operation does not prove that a system was safe. Both claims require records. warning signs demand even greater care. After a catastrophe, ordinary imperfections can be made to look prophetic. A documented anomaly is not automatically a warning of the exact failure that followed. Investigators must ask whether the anomaly was observed, whether its significance was understood at the time, whether it was communicated, and whether an available corrective action was rejected or merely unknown. The supplied material offers no SL-1 anomaly reports, design constraints, inspection findings, or prior incidents. Therefore, there is no support for claiming that a specific warning was ignored. There is equally little basis for narrating the failure itself. A credible event sequence requires time-linked observations, instrument records, physical evidence, witness information, recovery findings, or an investigation board's reconstruction. Those sources help distinguish what was directly recorded from what experts inferred afterward. They also reveal where the evidence ends. Here, the SL-1 sequence is absent, describing a control movement, power excursion, explosion, pressure event, or structural failure would introduce facts not found in the supplied ledger, even if some of those details might be available in outside histories. The consequences are also undocumented in this pack. The title implies fatal consequences, but no SL-1 casualty figure or official classification is supplied. Even the comparison embedded in deadliest requires a defined category and comparative evidence. Does the category include experimental, military, research, and commercial reactors? Does it count immediate fatalities, later radiation-related deaths, or both? Those definitions are not semantic distractions. They determine whether the superlative is accurate. The Chernobyl excerpt demonstrates the complexity of such accounting. It distinguishes engineers killed or injured around the explosion, workers hospitalized with acute radiation syndrome, deaths within several months, later deaths from various causes, thyroid cancer cases, and modeled long-term estimates. It also calls Chernobyl the only instance in commercial nuclear power history involving radiation-related fatalities. That commercial qualification matters. It cannot establish how SL-1 should be categorized, nor can Chernobyl's casualty framework be transferred to a different accident without supporting evidence. Investigation findings would normally narrow the uncertainty. Physical deformation might indicate the direction and magnitude of forces. Reactor records might establish the order of events. Design analysis could identify how reactivity changed. Institutional documents could show what hazards designers considered credible. Competing explanations could then be weighed by how well each fits the evidence. But no SL-1 investigation report, agency history, technical paper, regulator record, or court document is included here. There are consequently no supported competing explanations to compare. That absence also blocks a defensible root cause analysis. Operator error alone is rarely a complete technical explanation because engineered systems determine which actions are possible and how severely mistakes are punished. Yet blaming design alone can be equally simplistic if procedures, maintenance conditions, or unauthorized actions materially contributed. A proper analysis asks why one failure could bypass multiple protections and whether those protections were independent. For SL-1, the supplied evidence cannot answer any of those questions. The organizational layer is similarly unknown. There is no record here of who owned the reactor, who supervised its work, how responsibilities were divided, what training existed, or how risk decisions were reviewed. It would be irresponsible to invent schedule pressure, secrecy, inadequate oversight, or a cover-up simply because those themes create drama. An investigative narrative becomes anti-scientific when it treats suspicion as evidence. The ethical layer must also remain separate. Every hazardous research program has obligations concerning worker protection, informed risk, emergency planning, and honest communication. But a general obligation does not prove a specific violation. To establish an ethical failure at SL-1, The evidence would need to identify a known hazard, a responsible decision, and the people exposed to its consequences. None of that documentation appears in the source pack, nor can the episode accurately explain what changed afterward. Consequential accidents often influence reactor design, operating rules, emergency response, training, or regulatory practice. Yet attributing a later safeguard to SL-1 requires a source making that connection. Chronology by itself is not causation. A rule adopted after an accident was not necessarily adopted because of it. No post-accident reforms tied to SL-1 are provided. One supported lesson does emerge, but it concerns investigation rather than reactor physics. Catastrophes invite tidy narratives: one reckless act, one hidden defect, one ignored warning. Real failure chains are usually established by separating observation from reconstruction and reconstruction from interpretation. The Chernobyl excerpt supplies enough information to begin that process for Chernobyl. It does not supply evidence for SL-1. Using it as a substitute would produce the appearance of technical depth while erasing the differences that actually explain accidents. A valid SL-1 episode therefore requires a corrected evidence pack containing authoritative, topic-specific records. At minimum, it needs an institutional account of the reactor's purpose and design, the official accident reconstruction, documented casualty information, findings on technical and organizational causes, and records of subsequent safeguards. Secondary histories could provide context, but the central claims should remain anchored to those primary or institutional findings. Only then could the narrative identify the decisive force that defeated the expected outcome without turning uncertainty into spectacle. The honest conclusion, based solely on the supplied material, is that the cause, sequence, consequences, and legacy of the SL-1 accident cannot be established here. That uncertainty is not a verdict on nuclear science, nor evidence that the event is unknowable. It is a boundary imposed by the record currently available. Respecting that boundary is part of scientific judgment. Claims should become stronger only when the evidence becomes stronger. This content is for educational purposes only. Do not attempt to recreate any described experiment or procedure.